Hello and welcome. Today we're continuing with our discussion on alkenes, and we're looking at how to assign E or Z configurations. So for E configuration, the high priority groups are on the opposite side. So if you have a double bond here like this, then you have one priority, the high priority number 1 there and high priority number 1 on the other side. While for Z configuration, the high priority groups are on the same side. So you'll have number 1 there, then double bond, and then another number 1 there. Now looking at this first structure, you see that the double bond goes this way. You need to cut the double bond into 2 halves. Now let's focus on the left hand side. Here we're looking at oxygen and hydrogen. And you'll see that oxygen has a mass of 16, while hydrogen has a mass of 1, and therefore oxygen will have a priority of 1, while hydrogen will have a priority of 2. Now let's look at the right carbon. Here now we are comparing nitrogen and chlorine. Chlorine has a mass of 35.45, while nitrogen has a mass of 14, and because of that, chlorine has priority number 1, nitrogen has priority number 2. Now, if you focus on the high priority on the left, it's up, and then high priority on the right, it's down. So you end up with something that looks like that, 1 and 1. And because they're on the opposite sides, it becomes E. So that's an E alkene. Next question. We now look at this double bond here, and we need to divide it into top and bottom half. Focusing on the top half, now we are comparing oxygen and carbon. Oxygen has a mass of 16, while carbon has a mass of 12, and therefore oxygen will have high priority. We label that as number 1, while carbon will be number 2. Next, let's focus on the bottom alkene carbon, and now you're comparing that carbon and this carbon. They're all the same. Then you move to the next. You see that this carbon is connected to this other carbon, while that carbon is connected to the other carbon. The carbon on the right hand side is connected to this other carbon, while the one on the left is connected to a carbon which is connected to another carbon. Because of that, the left side has higher priority, and therefore you label it as number 1, while the right side will be number 2. So you end up with high priority on the same side of the double bond. That will be a Z alkene, because the high priority groups are on the same side. The easiest way to remember it, use Zem-Zide. Zem-Zide for Z alkene. The last example here, again we divide the double bond into 2. And if you look at the top half, you have oxygen with a mass of 16 that will have high priority compared to nitrogen with a mass of 14. Then when you look at the bottom half, here now we are comparing carbon and carbon, same priority. But the carbon on the right is connected to oxygen, so that's almost like carbon, oxygen, oxygen, while the one on the left is just carbon, carbon. So that means the right-hand side wins, and therefore that's going to be high priority number 1, while the left will be lower priority number 2. So you end up with a double bond where now the high priority on the top carbon is on the left, while the bottom carbon is on the right. So you end up with something that looks like that, and you can see that that's on the opposite side of the double bond, and therefore it becomes an E alkene. Thank you very much. If you enjoyed this presentation, please support the channel by subscribing. Feel free to leave a comment and also like the video. Bye.